Would somebody like to pick a number between 1 and 12?
12.
12? Another one? I should probably look at the traffic before I do too many more. Another one?
That's his production, right?
Yeah. That's the point of the talk, right? Another one?
7.
7. You sure? I like number 7. Nah, 7's dead already.
1.
Shh. All right. Hi everyone. I'm Pete, and I work at Just Eat, although only for a couple more weeks. And this is a talk about how we can get away with stuff like this on stage. We're running in AWS. This is the production account. There's no trickery here. I haven't gone and renamed 12 instances of Consumer API in QA, because we only run one of them, and I'll prove it. Do you trust me?
Yeah.
Yeah, okay, fine. And essentially, we're in the AWS cloud, and we're trying to be cloud native like those people at Netflix do. It's a Windows platform. I hope you're all happy customers. I mean, should I do the introduction of what Just Eat is? Sales.
Anyway,
okay. Online sales channel for your takeaways at the end of your street, basically. We put the menus online. We make them searchable. We allow Google to find them with various tricks, just like any normal website in the 21st century. And customers come along hungry and buy food, and then we tell the restaurant, please send the food to here because they paid for it. And that's the business, really. I mean, there's a few more things, but essentially that's the core flow. We've been going since 2001 in Denmark. We launched in the UK, which was our second country in 2005. I've been with the business since 2010, and we're now in, I think, 13 different markets around the world, some of which we are in organically, some of which we've M&A'd our way into, and so they run their own platform still. At some point, we might actually converge them. So, yeah, cloud native in AWS. That basically means that it's not an event when a server dies. It's an event when a few servers die, but not that many. And so one other thing I should probably baseline is, how many people here are familiar with AWS in general? Most of you? Okay, so we run in Ireland, a single region. We do some failover stuff to Frankfurt. And we read that bit of the manual that says, put your stuff in more than one AZ. So we did that right at the beginning in 2013. And that means that it's not really a big deal if a couple of servers die. In fact, that's our preferred debugging technique when something goes wrong, is kill that server and see whether the next one does it again. Because that's the quickest, easiest thing to do when you're on call in production, because we're all on call in production, and maybe PagerDuty will tell me that I should do something. No, it's fine. And so we made the decision very early on, as I say, that a loss of a server is not an event. It's not a human interrupting thing. Loss of an AZ, that's an event. But that hasn't really happened an awful lot, and so we don't really expect it to happen very often. Occasionally Ireland gets hit by lightning, but so far Ireland hasn't sunk, so we're good with just being in Ireland. We made the going-in proposition that we want to run at no more than 2/3 capacity utilized, because we want to be able to weather the loss of a single AZ. And if I had the AZ chart up here, then that might have been a better way to pick the numbers. So killed one in A, killed one in B. That one was already dead in B. So C had more, and A and B caught the brunt of that. So yeah, everything that we run is essentially CloudFormation doing its thing to run CFN init, which at this point now kicks off code deploy, but didn't used to. That's a reasonably new addition. We've been running on this iteration of the architecture for 3.5 years, something like that. In fact, when we moved to AWS in the first quarter of 2013, we had our highest recorded uptime to date in the midst of that migration. As you can see, we tag things. We tag things so that we can do things like cost breakdowns and performance breakdowns. We can tell the difference between EUS1A versus B versus C in our stats to see whether there's, well, one zone is running badly. And we do sensible things like that. I'm sure you do similarly sensible things. I should have said at the beginning, if you've got any questions, then shout them out as we go, because that's a bit more entertaining. This is a free-form talk, and I also later have an actual talk with slides if you're interested, which is why we run fake load against production. But yeah, we're just waiting for those 3 victims to come back, and we should see some yellows, initializing. So everyone familiar with the sort of instance life cycle? You get them provisioned from AWS, you wait ages because they're Windows instances, and then finally they boot. And then CFN init runs from user data, code deploy runs and goes and gets the package, downloads it, unzips it, does the thing. At this point, I think we've found all of the ways to deploy a website in IIS on Windows. We've only just recently standardized on just one way of doing that.
So is that like an MSI?
No.
Structured thing?
No, it's a zip file. So early on, and before AWS, we had we defined a contract for what is a deployable thing. And it's something that can be unzipped with 7-zip, or zip. And in it, there's the build output, there's the deployment automation, there's the configuration. So that package is immutable between environments. So we promote stuff and have done that for about 6 years. It's just in the beginning we didn't have the cloud. And in fact, we didn't even have automation to deploy stuff. We just had people. And they hated it. So, yeah, we don't have configuration management in production. We have CFN init and we have our deployment automation. So we took the view that we could learn Chef, we could learn Puppet, but 3 and a bit years ago they sucked for Windows, or they were just fledgling support for Windows, so we decided not to. And CloudFormation was good enough for what we needed to do at the time. There we go. So that is me on call, because I took it, receiving an alert to say somebody's being a dick in production. And I shall acknowledge and resolve that, because...
Is that because too many instances are down at the same time?
No, it's because we've got a bug in our health check, which... So our elastic load balance, everything's fronted by an elastic load balancer to an auto-scaling group. And our health check in this particular feature is dense. What it does is it kicks off requests to the dependencies of this API to see whether they're alive. And that's a really bad idea, because if they're not alive, then we can't bootstrap any more instances. So you get a cascading fail. So, yeah. As you can see, we use HipChat. Persistent group chat is invaluable doing operations because people can see what's going on. If you remember to route the alerts into the right rooms and not drown out the actual people speaking there. We don't do a fantastic job at tuning the alert noise, as you can see. But on the other hand, this acts more as a log of what's going on in production than a place to chat. We open incident rooms if it's an actual incident and not just a sort of, oh, it's that. So, I was talking about configuration management. We got an awful long way with Amazon by not doing configuration management and just building an AMI, an Amazon machine image, a server snapshot, right at the start, and that person installed IIS, installed .NET frameworks, installed the various things that we needed to run and didn't write it down and baked that as an AMI, and then for the next 2.5 years that's what we used. We occasionally updated it with security patches. It took a hackathon to introduce a build script for that AMI, and now we use Packer to really, well, that's a really nice thing to use, we've discovered. Packer is one of the tools from HashiCorp. I'll stop talking about HashiCorp things if you will nod and say you know what HashiCorp things are. Yes? No?
Some people will.
Okay. HashiCorp does really good operations tooling. Packer is their build script for machine images, and it's cross-cloud.
Same people who make payments.
Yeah.
For console and Vault.
Yeah. We're in the process of getting console into production, so we can do things like change configuration at runtime rather than have a deploy trigger that. And also then we'll get Git for our configuration data, because there's a Git to console project that allows you to synchronize various Git repositories, and so that's really good too. We're just waiting for the Windows bootstrapping. I'm pretty confident that they'll come back, because this isn't the first time I've done this. Has anyone got any questions so far? Yes, at the back.
Do you ever need to, I mean, in our world we SSH sometimes in the servers.
Yep.
In the Windows world, what happens in production? Do you are desktop in the server?
Well, we don't use SSH. Yeah, so everything, all of the instances that do not themselves hold data, so SQL Server, MySQL, all of that stuff aside, all of our things are stateless. And so that means that the logs get shipped off to Elasticsearch logs-Kibana. The real-time stats get published to a Graphite server, and any transient data is processed and got rid of as quickly as we possibly can. That means that I can get away with stuff like this with a minimum impact, because there is no data to lose other than perhaps the in-flight requests. And usually those will be retried. I say usually because I'm not aware of all of the clients to the consumer API, even though I own it, which is bad. But you know, the typical thing will be the user gets, oh, an error happened, retry. And so it's not perfect, but it's also not terrible. So we don't have any sticky session going on for our load balancing. Finally, we got rid of that in the last component that had it in Q4, because we were using the ASP.NET session state service, and when that went down, we were sticky to an AZ. When that went down, everybody in that AZ lost their session, which was terrible. Only took 4 years to get rid of. Did that answer the question?
Yeah. And do you run Elk on Windows?
No. Why would we do that? That's crazy. No. So all of the money-making stuff is .NET and mostly C#, some F#. All of the deployment automation is now PowerShell, even though I hate it. And all of the non-money-making stuff, the stuff that props up the Windows stuff, is anything but Windows. So we use the Amazon Linux AMI distribution because they optimize that apparently. And we host Elasticsearch and Logstash on that, and we host Graphite and StatsD and that stuff on that. We are flirting with ElastAlert, which is a pattern matching thing for Elasticsearch, and we put that on Linux. All of the things that you don't need Windows for, you don't use Windows for. Yeah, because of the long bootstrap times. And basically, whenever I go and work on a Linux feature, I'm reminded of how long the damn thing takes to stand up compared to a real computer.
Windows 2012, you're putting that?
Yeah, Windows 2012, R2, and all of the various service packs.
Is that all of the tiers? Or we're seeing there some SQL web servers?
No, sorry. You're seeing one of about 120 different collaborating features of the platform. So loosely speaking, we have a CDN layer, and I think we use Encapsula, but well, whatever the CDN layer is. Then we have, for certain public-facing things, we have an HA proxy tier, which we run ourselves. That balances traffic to the web serving tier, which is what we call the public web and the public API, and a few of the other externally facing things as well, but they're smaller. And then underneath that, underpinning all of that, are some internal APIs. So we're loosely decoupling to things that speak HTTP rather than integrating through one massive database, big ball of mud database. We still have that big ball of mud, but we are now constraining access to it to vertically sliced things. And we're doing that so that we decouple teams so that they can make progress on their own without waiting for dependencies to other teams. So one of the things that's accelerated that a lot is using Swagger to document our APIs. We actually generate it. We don't do contract first development, but we do agree on the contract on the API side and the consuming side before we do a lot of the coding work, when we remember. And that makes it go better when we do remember. As well as this, we also have some serverless stuff with Lambda and API Gateway, as a very successful experiment. But I don't have a talk on that.
What kind of things are you putting into Lambda? Because we've got half an eye on it.
So
It's very different the way we've got
we have an equivalent workload of 3 Windows servers, T2 mediums, and a Lambda, listening to the same SNS topic event stream, and just the hosting cost is 80 times cheaper for Lambda, and we don't. That's on top of not having to deal with caring for servers, scaling servers, patching servers, knowing that they're up or down, all of that stuff. We have not yet ingested the CloudWatch logs into Elasticsearch, so that's still a little bit ropey. But on the other hand, if you log in structured data anyway, then CloudWatch logs gives you a query syntax that you can use. So it's operable. It's not nicely operable, but it's operable. And then we use CloudWatch alarms defined in CloudFormation to alert on the various things that AWS give you as well. And we were able to do a new feature with Lambda, having never seen it or Node before, in, what was it, 2 months really, because we're in I'm going to pay a little bit of attention to this because I wasn't expecting that. Nah, that's fine. Totally fine. What could possibly go wrong? So yeah, Lambda was a very successful experiment, and more teams are using it consequently. Even just for the event processing, for 80 times cheaper, we can train people to use any of the languages that Lambda support compared to running stuff with Windows. Deploying a Lambda is as fast as it takes to either put a 2.5 meg or whatever it is zip file, no more than 50 meg because that's the limit, zip file up into AWS, or do that but deploy dark because it has features for deploying dark, and then flipping an alias to actually release. So I think at this point all of those things are back. We should have 16, because one of them was booting when I came here, running green instances. And that is the Chaos Engineering at Just Eat talk. Any questions on that?
What are the health checks that you do? How does the application know that it's healthy?
So we have a series of those. Let me show you a typical. I guess Runbook is a reasonable start. So to make it possible, as opposed to easy, for people to be on call for their stuff in production, we write stuff down. So every COG team, component ownership group, it's a horrible name, but there it is, has a README repository which talks about how people should engage with them. The COG team, it owns components running in production, and then separately there are feature teams that want to change components to enhance them, or to make them, to enhance them. So everybody in engineering at Just Eat is sat in a feature team, and at least one, but hopefully only one, COG. So there's immediately a tension there, because am I working on feature work or am I working on COG work? All of the COGs have an on-call rota, and what it tends to be is each person is on call for a week and then it rotates. And it's up to the COGs how they do that. It could be, you're on call for a day at a time and it swaps on a day, but most people do it per week. And so what we find is we recruit developers, and developers are not necessarily operating in production capable yet. So how to debug in production when you can't hook a debugger onto something is a bit of a blank look when asked. But we train people. So had a lot of success with trying to teach people that you write tests that run before you deploy, right? I mean, who here does that? Come on, more, surely. And so these are just tests that run all the time. These are just tests that run all the time in production, or in any environment that you wire them to. And what they do is they're watching the metrics that your application is emitting and your servers are emitting, and then validating that you're within tolerances, because it's not just a true-false it works, it doesn't work, it's good enough or not good enough now. And so there's a tolerance. So we teach people that, you know, alerts are just different sorts of test automation to give you confidence that your code's working right now, as opposed to it worked just before you hit the deploy button. In terms of the insight we get into production, we have an old version of GraphHonor, but new soon. And this is a templated dashboard, which is a bit squished up on this screen. Sorry for that. I'll zoom out a bit and explain the labels. Showing us some, you know, the basic server-level resource metrics that a Windows Server admin should at least know about, maybe care about. You know, can't have everything. So here is the moving average of the worst CPU, and it's a good at-a-glance thing to have. Well, what was it a week ago this time, just as a sort of an eyeball check? Because if it was weird a week ago, then that's somewhere to start looking. Did something deploy in the last week that's a bit contentious? We've got the time spent garbage collecting, and for this one it's quite good. For most of our stuff it's really not. We've got the Pete was killing stuff in production chart over here. So you can see the instance count dip and then come back up again as things come back. We've got the exceptions per second and the exceptions count charts over here, as a sort of broad resource metric. Is this weird? As opposed to, oh, it's this particular operation that's broken. And so this is sort of the table stakes for monitoring, I would say. Is your infrastructure okay? If an alert at this level fires, then you're missing coverage in production that will tell you what is broken, as opposed to having to go and find it out. So I would say that we encourage people to do the thinking ahead of the problem, so that you write the test to expose what might be failing. So for example, the consumer API hosts the login operation for the platform and hosts the sign-up operation for the platform. And so a decent set of alerts for the consumer API might tell me the percentage error rate for the login and the sign-up operation, and the response time compared to what we want it to be for a performance budget sort of thing. And those aren't necessarily things that have operational responses in production, other than do some investigation to figure out what the problem is. Because we're not quite at the level of we can write a hotfix on the hook in production when the world's on fire and push it. We're still at the sort of stage of, well, the world's on fire, fuck, but let's fix it tomorrow. Or let's have a look for feature toggles that might still be there and turn them off frantically and hope that they still do what we think they do. So we're not perfect, but we're trying. Other than the cluster health dashboard, each team that owns a component will usually create a dashboard that looks vaguely like this, except this is a terrible example because I've been working on it. So again, we've got some duplication, which I should really get rid of, but then we've got some status code counts, which would normally load, the upper 90 response time compared to the regular response time compared to the alert levels, whether this operation is throwing any exceptions and what type they are. That structure map exception is our inversion of control container. So if we see any of those, the immediate answer is roll back, because somebody has messed up the registrations of the container. That's a really easy one. And here we've got the call count to the various operations, again named, because knowing that your API is running slowly is not so useful compared to logins is running slowly. If you have a non-microservice, which a lot of our stuff is, then you don't know exactly where to start looking to figure out what the problem is and whether you have options to present to whoever's watching the world be on fire. And then we also have some message handling counters for stuff that we care about, and in general some our requests queuing, which is another decent way of knowing that something somewhere is blocked up. We also have things like the AWS SDK logs, and normally there would be some data here, but when we turned them on, we blew away the hard drives for our servers, because we harvest the logs written to disk as opposed to publish them directly from applications. So we're still tuning this. But what this would show you is the AWS health from the view of the client applications that we've written. So we would be able to see error counts against Dynamo, error counts against SNS, that sort of level. And then on the right, or on my right, we'd be able to see the error counts for particular operations within that service. So again, we'd be able to triangulate quite quickly on what's broken, and then raise a support ticket because there's no API for that. Damn them. But yeah, this is now only tuned to show AWS SDK errors, which is again really useful to have because we'll immediately have the Amazon request IDs to give to the Amazon support ticket, which will cut away about 30 minutes of waiting time because they'll immediately ask, well, have you got any request IDs? Fully expecting the answer to be, oh no, we didn't have that turned on. Now we do. We have code deploy activity. So whenever there's a line on here, there's an instance that's come up, either because someone has updated the code base package or because somebody has terminated some stuff and an instance has replaced it. And again, this is the classic thing. It's on fire. Well, what's changed? What did you do? And here we've got the web logs. So again, because a lot of this is structured data, we can create general Kibana dashboards and then parameterize them. So I could show you the consumer order API IS logs, and they would look vaguely the same, at least to the eye. So here we've got just useful visualizations to us. So things, the response durations are bucketed down into a sort of logarithmic sort of thing. The response status codes, let's get rid of 200s so we can see weird stuff. Let's see. Because if you have 200s, then you probably mask out all of the interesting broken things. And you know, those are tolerable error rates because an alert hasn't fired. We also have request sizes in case somebody tries to basically game us by shoving lots of data in requests and DOS us that way. That's a really good one to spot that sort of shenanigan. And response sizes for the same sort of thing. One of our menus famously is about 7 meg. And that was a shock to see it. Then we also have the Windows event log. So you know, this is a good place to go for. Well, we've exhausted the sort of usual suspects. What's going on in the event log? You know, what processes have come and gone lately that look a bit weird? This is a sort of last gasp. Don't really know what's going on, but let's have a look. Sort of dashboard. And then finally, we also have the application logs. And we recently, I say recently, in the last 6 months, we came to the realization that putting data inside of a string to then parse it is a terrible idea. So we stopped doing that. But not only do we have to write custom parsers per info.logger.info and logger.debug, which is insane, we also have to keep those configurations up to date for the log shipping agent if we use CSV, or worse, just a single line. And then we have inconsistencies between features, and we can't do anything. So instead, we realized that Logstash just wants a JSON document, and it will turn the top-level fields of that JSON document into Elasticsearch fields, and then you can do things like log an order ID that isn't an attribute that all of my components might log. It's the consumer API wants to log an order ID or a consumer ID, and so now I can search in Elasticsearch by that consumer ID, which is far more useful and far less pain to work with. And so that's what we started doing. We wrote a little log library extension to do that, and now we have structured logs. Any other questions on that sort of aspect of stuff? Yes.
What was it? I assume everything's written in C#.net.
Mostly, yeah. There's some F#. There's the native apps that are whatever the native apps do these days. I think some Swift in the iOS stuff and Java for Android. C# for the Windows Phone, but nobody has Windows phones, so I don't know that much. Yeah.
How did you find the integration between the Windows stack into kind of a monitoring stack based on Linux?
If you can glue strings together and pump them to UDP, then you can integrate to a Linux monitoring thing for StatsD at any rate. If you can write them to disk and then have something else glue them together and write them to UDP, then you can integrate. So really easy, to be honest. Our downfall was not constraining the names of the StatsD metric buckets. So everyone has a different idea about where to put the feature name of the thing that's publishing metrics, for example, in that dotted string of metric. Is everyone familiar with StatsD? Yeah, okay. Basically, a metric is a dotted string. The dots denote hierarchy. And then a colon and a magnitude and a pipe and a metric type. And our mistake was to not consider a metric to be an abstract thing to then serialize to StatsD, as opposed to we publish strings. So it's then difficult to change our mind about how we might order the buckets, because you get a tree hierarchy to explore down. Yeah, I wish we'd done that.
With the event log, I asked because I'm probably going to be asked at some point kind of to support Windows on a common platform. We've done some kind of research into this, so I'm just kind of curious as to what you can do.
So we use a thing called NXLock Community Edition, which is a source available but not open source Windows service that's actually cross-platform. I think it's written in Perl. I'm not really sure. We'll see. One of the two. It's not something I've looked at. And that has a perfectly reasonable configuration language to deal with the Windows event log. It just looks at the XML and goes, oh, that's structured data. And similarly, you can tell it to parse CSV, and you can tell it to read JSON, which is how we're doing the structured logs for our application log. And it's a little bit fiddly to learn, and it's also a little bit annoying that they don't tell you that you can use configuration file includes right at the top of the manual, as opposed to near the bottom of the manual. So our NXLock foray was basically initially, let's have a configuration file per 120 features. And so there was an awful lot of duplication, because everything wants a Windows event log, everything wants an IS log, everything wants a code deploy and CFN init log. And then we realized, hang on a minute, that's the same code all over the place, plus this little specific bit of application logs. So actually, we can just include a set of common files, and that was a much better way of organizing that, because then you can change the common includes and everything gets it. I hope at some point we'll open source that, but probably it won't be me. Any other questions on this bit? Yes?
For example, do you run the Windows servers like check mem, check CPU, check disk?
Sorry, could you repeat the question?
For example, let's say you have a monitoring infrastructure and you want to monitor the memory usage in a server.
Yep.
What runs the memory check?
So,
Nagios or something?
no, we found some code on the internet that would harvest the Windows performance counters and then just publish the value of that every 10 seconds. And then we found out that bits of that were broken, and so we rewrote some of it in PowerShell. And then 4 years on, somebody has created the Graphite Windows project, which we don't use yet, but looks really compelling. So it's, if you can get your performance counters to actually to either be read or emit CSV, which is one of the things you can definitely do, then you can publish your Windows stats without too much pain. But actually dealing with the Windows performance counters natively is a total ball ache. Any other questions? Okay, we'll do the second bit. Right. Who can tell me when peak time is for us? Of the week? But what time of day?
8 o'clock in the evening.
Yeah. And it starts... When do you think it starts? Yeah, about that. It's very literally, hey, person that I'm dear to, do you fancy takeaway tonight rather than cooking? Yes? Excellent. I'm just leaving work. That's basically when that starts, and then it stops when people are not hungry anymore. because we fed them. So this is a talk about how we try and make sure that we're not terrible at that. And as before, shout them out as we come. So I've talked about who Just Eat are, and in the context of this talk, performance is, I guess, at the head of the funnel, at the wide bit, about 70 searches a second. So you search for you tell us where you live, and that's a search for us, or where you want takeout from. And then the tip of the funnel is about 1,000 orders a minute also. And those are figures that are public, so no doubt they're a bit further on than that at the moment. But yeah, 1,000 orders, 1,000 e-commerce transactions a minute is roughly what we're talking about here at peak time. And we know when peak time is. It's basically when we run fake load against production. So this red line is the total tip of the funnel that's happening. This blue line is us ramping up fake load against production, and this is real orders happening, the green line. And we do that every night to basically prove that we have capacity for sudden spikes, and we do it so that we can turn it off if there's a real problem, because that normally gives us time to think, and a bunch of reasons basically. So we've touched on this. We've got cyclic demand every night between 5 and 9, something like that. Friday and Saturday are the busiest days of the week. Payday weekends are the busiest days of the month. We're busier in the winter when it rains because people don't want to leave the house, other than the delivery drivers. And our busiest day of year to date has been a Valentine's Day, which is just so sad when you think about it. Do you fancy a romantic takeaway? Yeah. But yeah, cyclic demand. And it's really predictable. That's key. So we use that to good effect. So the problem with continuous delivery is that everybody wants to change the system all of the frigging time without telling people why they're doing it, basically. Because you're empowering teams to do that because you want to ship faster. You want to get the features out the door. You want to fix things really quickly. You don't want to wait. It's the 21st century. And so we needed to still have performance testing. This was sort of back in the days when we weren't in the cloud. We still had a performance test environment. And we went with the standard sort of thing. Let's make an environment like production. It'll be fine. It'll be enough like production that we can get an idea. And it was, but there are a bunch of problems with that. The tests take a while because you want to stress the system. Probably, 5 minutes isn't going to cut it. You probably want about an hour's worth to see trends on graphs and that sort of thing. And the problem with engineers and things that take a long time is they get bored and they walk away. And so, how many people here have run a performance test that's supposed to last an hour, and you press the button, the go button, and then you've wandered off to get some coffee once it's spinning, it's fine, and you come back in an hour's time because it's going to run an hour, and it failed in the first 5 minutes. No, 2, 3. Oh, surely more of you. But of course, we had a single environment, and we had about 5 different teams at the time, and now we have 16 teams. So that didn't really scale too well, because if you have a bottleneck to get through into production, then everybody wants it. And because of the nature of performance tests and how they break things when you're not very good at running scaled code, because we weren't back then, it gets broken and it doesn't get cleaned up. And so the next person in has to fix it and figure out what you did and roll back to the versions that are in production and finding out and it's horrible. And so you have all of these problems. So we obviously didn't want to slow down feature delivery. So how are we going to fix this? Test all the time, basically. How did this get? So test in production. So I swear I heard these quotes around the office, and the group of people that had the most problem with the concept of testing in production were actually the engineers, not the managers, not the execs, although they probably had some problems with it, but we gloss over that. But yeah, it was the engineers. What could possibly go wrong with this approach? I mean, surely everyone does this. Turns out not. So, reasons why this isn't insane. Basically, in a performance test environment, you don't have the other load agents, your customers, doing weird random stuff all the time. And so you can't really, well, we couldn't really come up with a cost-effective way of simulating real production load against a different environment that's not quite the same as production, and still for that to be measurable and pass. But it turns out that when you put your engineers on call, they have a higher incentive to care about the non-functional stuff, and also push back on the people that are so far removed from it, the managers and the people that might not be so technical, about yes, it functions, but it's not ready for customers yet. It's not fast enough, or the error rate is too high, or weird stuff happens when this happens. And so it's acceptable from a functional point of view, but it's not quite ready yet.
What level do you go to with the test? Is it full suite of constant test, full features and functionality?
So that, for the fake load, we decided to cover the core path. Customer must be able to buy food, and some paths around that. So customer must be able to buy food with cash, or online, or with Apple Pay, or that. Fundamentally, customer must be able to buy food, because and more than one customer too, from a wide variety of shops, and that implies, yes, we have test data and test areas and test countries in production. And some of them have real customers in them as well, because the smaller ones we shamelessly abused as a test environment to begin with. And we have test users, and I'll tell you a funny story about the test users in a sec. But yeah, we have test data in production. But then for the other testing that we do, it varies per component. So for example, the consumer API has a suite of unit tests that run in process. It has a suite of functional tests that run against a deployed instance, and then it has a set of deployment verification tests that run after a deployment has happened. And different components will be at different sophistications of those. The newer components run entirely in memory because they're taking advantage of newer frameworks that let you do that, and the older ones don't. But yeah, as I was saying, engineers are on call, and so when you put your engineers on call, you get the platform slowly becoming a little bit more operable, and because the engineers don't want to get interrupted in their personal time, so they do the things that stop that from happening, and sometimes they lie to the managers about what they're working on because they don't want this to happen to their personal lives. And to me, that's all fine. I'm an engineer, just in case nobody had guessed. And sorry, we also have things like real-time monitoring, which I've talked about already, real-time logs, which are centralized and queryable, so we can debug in production quite readily. Not perfectly, but reasonably. And we have the platform that will tell us when it's unhappy, and we can escalate to different teams to help us out. It's not like, operations is a team sport. It's not like I'm on the hook for my bit. If I'm on the hook for my bit and something goes wrong with it and I don't know what the hell's going on with it, and I'm going to escalate to somebody who does. And that's all part of the game. So we started doing this mid-2013, I guess. And we started out with disbelief that, as those quotes showed you, why would we do this? What possible reasons could we have for doing this insane thing? And it grew from there. We started out with figuring out what technology we're going to use and which people we're going to have to convince and how to do this. So initially, yeah, we had the idea to start, and there's prior art to this. This wasn't our bright idea. I think Dropbox, that post links to a Dropbox engineer that talks about how they do this and how they've been doing this for more years than we have. But basically, our director of engineering read that and thought, that's fantastic, let's do that. And so gradually we did.
Still have test environments.
Oh yeah. But this tells us we've got capacity for 6 months and we've got a release valve, compared to a test environment is, rather than 12 consumer APIs, you get 1. And yes, it's still load balanced, but the traffic through it is not going to cause the ELB to run out of capacity and scale, which is something that does happen in production. That's why you saw a ramp up as opposed to a fake load now, because the ELB itself has to figure out there's more traffic and has to have time to scale behind the scenes, which you don't see in AWS. So we started by choosing the scenarios we care about. Initially we had fake load at justeat.com as a user, and he can buy from this restaurant that we hide in our UK database, and that restaurant can sell pizza and nothing else. Margarita pizza at that, really boring. So that user now has several million margarita pizzas to his name, and we grew it from that. And he didn't even get to order the pizza to begin with, because ordering was a component of the platform that we hadn't extracted from the monolithic part yet. We were still working on the system as we did this, so we were still extracting to those internal APIs. But yeah, we talked about how far through the funnel can we get that makes sense, and the value that we'll get from doing that, and then the value add of going one step further and one step further and one step further by now there's 2 fake load users. Woo, look at us. And then there's 20,000. And then there's more than one fake load restaurant, and then there's, actually I'm not sure there's more than a few. I think there's just one. But anyway, growing the coverage, I guess. We chose a load agent. Who's done some perf testing recently? What did you pick? Why did you pick that? Yeah, because it looked cool. For some reason, we chose JMeter because XML is great, right? It's an arbitrary choice. It's the 21st century. You can find something that will generate load against a website, and you can probably start with your functional tests and just run them in a loop, because they might even tear down stuff afterwards, if you're lucky. But yeah, we chose JMeter. It's got a GUI that you can use to record your tests. It's got some capabilities around injecting some random data as opposed to just using fake load user, number one. And yeah, you can use whatever you want. We picked that one. We didn't do this at peak time to begin with, because we were terrified. And so we did it initially very early in the morning, possibly even before the start of the working day, although I don't actually remember. It was probably not before the working day, because we were still, well, I think we'd got to the point where we didn't want to do stuff in personal time at that point. And so we just said no. But yeah, this was a bit about reassuring the various stakeholders, the engineers included, that this is not a terrible idea. And so things like, well, what's going to happen if we fill up the database with fake load orders? Well, there's going to be more fake load orders in the database. That's not the end of the world for us. And actually, it tests the capacity of our database, so we can see that it's going to run out of capacity much sooner, because if you think about it, we can reclaim all of that space by truncating particular tables. Actually, we can delete stuff from there with a where clause, not a truncate table. That would be bad. So yeah, we baby steps. We dipped our toes, and it went well, reasonably. We started adding data variety, so more than one fake load user, more than one fake load restaurant, more than one pizza. Basically things to bust caches, because we have caches in our system. And then crucially, you make the computer do it every day. And still in the morning, not necessarily at peak time, but you schedule it, so you have a cron job. And we use TeamCity because it's a very convenient but terrible place to put a cron job. And yeah, you have that. And so then you watch your charts, and if the alerts go off, then you fail the test, and so you stop fake load, and your alerts probably go green. And that's basically what we do. But the crucial part is we get the computer to do this every day, and we don't allow it to not be running, because it's like a test. You invested the effort in the test, so let's have the test run. You can get more elaborate later. So we have a magical header, this is not that, to fake away some external dependencies, like our payment provider. It turns out our online payment provider looked at us a little bit askance when we mentioned that we might do this to them, And so they said, no, please don't do that. Well, why not? You say you can handle our load. This is just 50% more of our load. Please don't do that. So, okay, we wrote a thing that fakes being the payment provider. So it'll just say, yes, you paid. Well done. Whenever we try an online payment. But this blocked us having online payment coverage until we wrote that test harness. I don't think it's any smarter than that. I don't think it fails a particular percentage or injects latency or anything like that to make it more real, but it's good enough for functional performance. Functional performance, is that a thing? Yeah, the reason I'm not telling you the header is that for a while it was possible to get free food. And there were some shamefaced looks when we discovered that, oh yeah, that's totally possible. But you know, you'd have to be an engineer to get the free food, so that's, oh, hang on a minute. And so yeah, you can fake away more complicated things as well, like we have the magic box in the restaurant that we send the actual order data to, and the receipt gets printed out, and the beeping happens for the restaurant to start cooking the order or tell us no. And so if we're able to change the firmware of that to ignore fake orders, then we'd be able to expand the coverage down the GPRS network. And probably finance would get involved at that point because GPRS is quite expensive for us, but at the same time, it's quite valuable to know that the receiving end and the network can handle the capacity. Probably would have a feature toggle for that if we introduced it, because we've found out that that's quite a good idea. But yeah, how have we kept doing this over years? It's been a few years. There have been some clangers along the way, and so this part of the talk is about that. So I guess the first obvious thing is, just like any other test, don't let it be read for very long. If it flickers, find out why it flickers and stop it, just like any other test. So if we have a problem in production that stopping fake load is the answer for, then the next day figure out why it was the answer and rectify the situation so that in the evening fake load can run. It's just a test, right? If a test flickers, you find out why it flickers, or you delete the test, or well, there aren't really that many other options. We needed to tune the levels over time. So one of the things we kind of forgot to do last Christmas is up the level of fake load, because obviously we grow as well, because we're wildly successful, happily, and the fake load line was below our real order line, so it wasn't giving us as much confidence as it was before in our capacity. And so we remembered that, and so we turned up the level and went, oh, it'll be fine, and it wasn't. So then we fixed some things and got better. You need to get smarter about data management. In our case, this means that when you have a single table to store all of the orders in the history of your platform since it started, that means that you have to be able to scale the SQL Server data nonsense underneath that, or you have to be able to store the orders in different tables or have a view ahead of them. Basically, we have to be able to drop the fake load data in an emergency, and when it's all in a single table, that's not actually that possible with the infrastructure that we have in place. In that serverless thing that we talked about, we have an Elasticsearch cluster as our backing store for that stuff, and we have features of Elasticsearch to store the data in indices that have the date component in them. So we have order data 2016 month day, and we also now have fake or real components of the name there. So we can very easily, as an operator, go and kill all of the ones that have the word fake in them, leaving all of the capacity free for real data if we have a problem. Yeah, you have to be honest about the stuff that will break, because stuff will break the first time you do this, even with the baby steps and the softly approach. It didn't go so smoothly when we introduced it, and we still have problems. And so you have to be honest about the fact that this is valuable, and we're doing it. You have to keep in mind the priorities for why you're doing it, and those priorities are: we want to have a very easy operational response, a first-line operational response for any performance-related problem, and that is go to the team city and stop the builds. Then that immediately relieves pressure from the platform and gives you time to think. In operations, you want time to think, because otherwise you make decisions under pressure, and those decisions are often, you don't have time to think them through. So that's the top priority. The second priority is to give us constant integration confidence in our core flow. So yes, there is a functional test aspect to this, but it's running in production all the time. We trickle it outside of peak time, but it's still running. And then the third one is we want to not do boring capacity planning. We just have this happen every day, and if the alerts go off, then we know we have to add some capacity. It's just got rid of a bunch of meetings and a bunch of budget decisions and a bunch of all of that crap that otherwise you'd have to do, and the computer is telling you, I don't have enough computers to service your requests. So that's really positive. So yeah, what did we mess up lately? Well, I can talk about all of these because most of them were me. We found you introduce an API operation, and maybe it's returning a list of stuff, maybe it's returning a list of orders, and maybe you forget to put paging on it because you're in a rush. And then you wire up fake load because that's the right thing to do because it's a reasonably central operation to our platform, and everything's fine for a while, and then fake load starts slowing down. Fake load starts spewing errors. Hang on a minute. Thousands of orders in the order history? That's insane. Nobody would have that. Yeah, but those fake load users do, because they're ordering every night. They're ordering thousands of times every night. And so consequently, if you don't put paging on your things that fake load is asking for, then that's going to be a slow operation in production. But we fixed it by turning off fake load, that particular scenario, not the whole thing, adding the paging, and then turning on fake load again. It turns out that the thing that's monitoring your web scale business needs to be a little bit more solid than your web scale business. So Graphite is the component that is the monitoring part of our platform. And we've gone through a few scaling exercises with Graphite, and last Christmas we realized we had to do another one really quickly. So we did that, we turned off fake load. Essentially, everybody at Christmas, we realized that we hadn't done capacity testing over the year by tuning the levels. And so there was a bright idea to, well, let's do that. So everybody scaled up to what they expected Christmas to be in terms of the number of instances in a cluster. And so 120 clusters now, doubling in size or whatever it was. And we bucket down to include the instance number. So in Consumer API you saw 12 instances and you saw those positions. That's what I mean by that. So from 12 to 24. And Graphite pre-allocates some space on disk for every bucket that it has. So now you just doubled the space requirements in a night. And that didn't go so well because we ran out of drive. And so monitoring needed to be a little bit bigger. We realized that, we're in AWS and we can scale elastically, but it's not our computer, fundamentally. They give you soft limits for bits of your account. So the number of EC2 instances that you can have at a particular size, they limit, because they don't want you to accidentally spend all of your money and therefore go out of business. I'm sure that must have been put in for that reason. And then helpfully, when you notice that you need to scale up past this limit, you raise a support ticket, and that support ticket immediately defaults to the lowest possible priority. And so consequently, they'll get to it in a day. So luckily, we found out that one of our instance types we hadn't asked for the increase for, and so we scaled up for fake load, and it didn't scale up, and we stopped fake load, and we asked them to increase the limit, and they did that a day or two later. Thanks, enterprise support, get what we pay for, and it was all good. But basically, if real load had happened, then it would have been a frantic call to AWS to say, we've raised a ticket, but you have to do this right now, please. And you can't really do that. They just don't respond that promptly. So, happily, we didn't see it at wartime. We saw it at peacetime. We realized that we weren't so clever at HA proxy configuration files. Somehow, somewhere, there was a thing that stuck all of the load to 1AZ, and we hadn't noticed in 2 years. Then we noticed, because basically all of our HA proxies in one region were cycling. Sorry, in 1AZ were cycling, because we were blasting them off the data center. And then the real kicker. Yeah, this is that legible? The image won't scale. I'll read it. I noticed the Apple Pay fake load is currently paused. This is me. We can re-enable that, I think. We fixed the problem with usernames being unique and that minor little knock-on effect of taking the platform down, right? So what we've been doing is we introduced Apple Pay for launch, actually. Yay, us. And we wired it up to fake load because it's an important part of our checkout procedure. And we used a fake load user with a single email address. So we only used one email address to fake load that. And for good reasons, we allow customers to sign up with the same user, with the same email address. So after about 6 months of Apple Pay, we had something like 320,000 of him in our database. And coming up to Christmas, our database is under memory pressure. And so when SQL Server's under memory pressure, it decides, I need to regain some memory. I will chuck away my cached query plans, and I'll recompile them. It's totally reasonable. But when 5% of your users table is taken up by a single user email, then it becomes a totally reasonable thing for SQL Server to decide to table scan when people log in. Yeah. That was I was actually at the WinOps conference talking about this very topic, and my PagerDuty went off, and it was that, and I had to leave. So yes, that's that. But yeah, the fundamental point is we're discovering these clangers during peacetime, not during the peak time. And so we have time to fix them. And so we gain a bunch of stuff. We got the continuous early warning about us getting slower over time, because we have performance budget alerts that if we breach, then we still have a little bit of headroom, but it triggers the conversation to product to say, hey, we could do some optimization work because our customers will get bored of waiting and will go somewhere else unless we do that. And we have data to back it up. We have, running out of capacity is a thing. It's really easy to change because we just scale up because we're in AWS, but it's still a talking point. We have that clear operational response to problems in production. So PagerDuty goes off, stop fake load, scale up. Now start thinking about what might be the problem, if it's still a problem even. And then the next day, look at that in more detail. We want the operational response to be as quick as possible because we realize that engineers that have just spent a whole day working are probably not at their best in an evening, and we don't want them to burn out. And then on that note, if we have a problem Thursday night, then the fix is simple, because Thursday night we run a Saturday load against. Turn off fake load, enjoy the weekend, fix it next week. And yeah, we treat performance and fast as a first-class citizen when we talk about product improvements and prioritization. And then we have alerts that are just different sorts of tests that are automated in production. And we're getting closer to the point of view of, well, why do we have these QA environments anyway? Can't we just do all of our testing in production? Because if we have that magical header, then that magical header could have a different value than fake. It could have scenario XYZ. And then if an API receives that request, it can return a pre-canned response. So now you have functional testing over the wire, one-level integration testing deep. And so you now don't have any dependencies on data in any environment, because you can deploy your thing, you can pull request the static data into your dependencies, and then you can deploy and test every 30 seconds. So you know that nothing is wrong. Well, very much less chance, smaller chance of things being wrong. And that's a slide that I don't need to show you because I'm not recruiting. Sorry. But yeah, that's that's why we run fake load in prod. Any questions?
Do you run any performance tests at all before you release?
Some teams might, but I think most teams don't bother, because we have instances that don't last more than a day, because we scale up and down to replace them every morning before everyone comes to work. So we've got fresh instances in production and in QA everywhere. So memory leaks and drive space drains they do happen, but because our instances are so short-lived, we just don't care as much. I mean, we still care a bit, but yeah.
If you have to, say, someone introduces an issue to the code that perhaps is horribly slowly,
Mm-hmm.
I think it's released, what would you do in that scenario? Would you just notice it from monitor and quickly fix
Yeah,
it?
so more and more components are having per operation type alerts. So operation average response time is greater than X, or worst case response time is greater than Y, or error rate is greater than X, or rather proportion of errors versus successes is too high. And the more that we have those, the quicker we can detect and be sure about the diagnosis to then roll back the small incremental deployment that it probably was, or not roll back but roll forward, because we probably detect it quickly enough that we can fix it quite quickly. That said, there are some times where we took down the platform for well, we're using a very old web framework for a few things, and its route matching thing is not the intuitive work of art that it could be. And so we had one case where our health check response had the same response type as our clear cache operation, and it matched both of them and called both of them. We matched one of them but called the other one under the hood without logging, and so all of our responses were going directly to our data storage rather than to our various levels of caching, and that was a big problem. But we found it, we fixed it. Yeah.
Do you think there's an increased cost to running this extra load?
Yes, of course.
Have you ever had any resistance to that, or people understand the value that they get in return for it?
There's probably been resistance to it, but that's probably been combated at levels above me, because we're still doing it 3 years later. There's also resistance from particular groups within engineering to do this, but they are not so. They're more operations than developer focused. That we don't really have developers and operations. We operate our own stuff, but there is a group that only sees the problems that this introduces, and so they're currently the people that have to explain to the business why we were down, or why we have these problems. That's changing, so that the business now comes to the owners of the components that are having the problem, or the middle management actually. But yeah, the onus is. They are trying to push for a staging environment to push things through on the way to production, which devalues all of the fake load in production because the customers don't use staging.
So we have to have separate performance environments, which again, because we've got so much config management, we are confident they look very much like production.
But probably different sizes, right?
They're the same sizes.
Oh, okay.
So it is matched, but we have some pretty good scenarios that we play. But I think this is a really interesting approach.
Mm-hmm. One of the other things I've seen done is, or heard of people doing, is teeing the requests. So you return the response from your existing system, but you still replay the traffic into a side-by-side system to then diff the responses and diff the performance.
Interesting. Any other questions? Well, Peter, thank you very much for coming in.
Pleasure.